teachers attending. What a wonderful way to end the afternoon or start an afternoon on this Wednesday with our math hour on probability. A warm welcome to all of you. I hope you're going to enjoy the session and learn a lot from our trainer that's going to be part of this session this afternoon. If you are wondering what the 21 Acts of Goodness are all about, I would just like to share it's an initiative of the Old Mutual Foundation where we as Macmillan decided, let's grab this opportunity. It will be a wonderful chance to help our class of 2020, our matric class of 2020, by providing some extra support and encouragement regarding mathematics. Today we want to show all our matrics attending this math revision session that with the very important final exams around the corner, please note, don't fear. Macmillan have your back. All the 21 Acts of Goodness partners are there to support you, as well as your teachers and parents. If you are struggling to apply your knowledge in maths, you are definitely at the right place this afternoon. We know you can do well in maths this exam. Welcome to the session. Thank you, Sejo. When you want to know how to use the control panel, it appears on the right of your screen. You can test your audio, and the wonderful news is you can also download all the material, all the examples of the activities that are going to be dealt with this afternoon. You can literally click on the little wheel there and download it. But we want you to be interactive. We want you to chat to us. We want you to actually give us answers to those questions. If you look at the little speech bubble, that's the chat function. You are welcome to type a question or give a comment or give an answer to anything that you would like to have more certainty about. Please interact with us. It's your session. We want you to be participating. I want to introduce our presenter this afternoon, Sejo Matlala. I told him just now, I wasn't very good at maths at school, but listening to him for the past 2 days, I think I can also go back to the class of 2020 and start doing mathematics. So Sejo, with your 23 years of teaching, lecturing and facilitation experience, including project management roles, we are so lucky to have you this afternoon. And to all the matrics out there, if you are considering going to the University of Joburg, you will definitely meet Sejo as a mathematics lecturer and a PhD student. Sejo is also part of the Macmillan Teacher Campus family, and we once again want to welcome Sejo. All the best for the afternoon. I know that you will be on fire again, and maths will come alive with your passion coming our way. Thank you so much, Sejo. Over to you.
Thank you so much, Martha. Good afternoon, learners. I hope you are ready for this session, and hope and believe that you will enjoy the session and you will learn something from this session. Today's session is based on probability. So I'm just gonna go through with you some of the basic terminologies that are important to probability. The terminologies are very important because you need them when you solve problems. You need to understand the terminologies so that you are able to solve problems. In probability, we have what is called sample space. Say, for example, in this session, our sample space can be grade 12 Macmillan class learners. And in this sample space, we have got 30 learners. So the sample space will be the observed individuals in a particular area. So in this case, our sample space will be grade 12A, which are the learners that are participating in this session now. And I've just put here that the learners are 30. The assumption is that we are 30 now, and that is what is called sample space. And then one other term that is important is what is called sample space. But now here, I'm showing you how we denote the sample space. We denote the sample space by using the letters N and S, meaning number of the individuals. That is, NS will represent the sample space. So for the example that I've just mentioned, then we will write it as number of learners in 12A. What is shown here, N into 12A closed bracket equal to 30. We read that as number of learners in 12A. That is how we denote the sample space. Okay. So that is important to notice, because when we do exercises, we're gonna come around with this. So when you see something like this, it means the number of learners in grade 12A, the number of learners that will be sitting in that class. If they are 30, then we will denote it like this. Then we say the sample space is 30. Okay, I see Tali saying I must repeat the first part. Okay, I'm just gonna go through the first part quickly, Ital, as you are suggesting. So I'm saying that here, that in probability, because it is something which might be new to others, it is very important that you understand the terminology. Understanding the terminology is important because we use this terminology when we answer questions. So the terminology is very important. So the first part of this presentation was that I defined what a sample space is. What a sample space is. Then I'm giving an example of, say, grade 12 learners. Assume that you are grade 12 learners sitting in one classroom. So all those individual learners that are sitting in that classroom, that will be the sample space. And if they are 30, say the learners sitting in that classroom, they are 30, then we denote that by saying, we denote the sample space by writing N into 12A equal to 30. So that means that the sample space will be the 12A. 12A is your sample space. So that is the notation here, N into S. N stands for number, S is the sample space, meaning the number of individuals sitting in that class. Then I'm saying here, the number of learners in 12A class is 30. And we read that as the sample space in 12A equal to 30. Okay, Tal, I think now you are on par with what we are doing. All right. Okay, thank you, Ital. All right, that's one of the things that is important. Sample space. Sample space, as I'm saying, it's the number of individuals in a specific environment. Say our environment here is the grade 12 classroom. Then we count the number of learners in that classroom. If they are 30, then these 30 learners forms our sample space. And how do we denote that? We denote that by using N into 12A equal to 30. And when somebody reads this, he will say, this denotes the number of learners in the class, in grade 12A class. And those learners in that class, they are 30. So that is what we mean by sample space. All right. So let's move on to the next terminology now. I'm just gonna erase what I've written there, the rough work that I did. And then look at the next terminology. B. B, if let's assume B is selecting a boy. Remember, in that 12A class, we have got boys and girls. So the letter B represents boys. And the number that I used here, 13, means that there are 13 boys in that class, right? There are 13 boys in that class, and the boys are represented by B, okay? Then G represent what? G represent the number of girls in that class. So the grade 12A class therefore means that it has got 13 boys as well as 17 girls. And remember, the sum of boys and girls must form 30, must give you the sample space. So B represents the boys, G represents the girls. The boys are 13, the girls are 17 in that sample space, in that grade 12A class. All right. Okay. Now that we know that we have got boys and girls in this class, okay, let's look at something in this particular class now. What does this notation mean to you now? P at B, or P multiplied by B, or P into B. This means the P stands for probability, right? The P stands for probability. The B here stands for boy. So this is something, this is a sentence. P probability, B the boy. So we read this as the probability of selecting a boy from 12A. That's very good, Ital. So we read this as probability of choosing a boy. So the notation is very important because as we move on, we are going to use these notations. So if you see P, say at B, looking at our sample space, which is grade 12A, it means the probability of choosing a boy in that class, in the 12A class. What the probability of choosing a boy amongst the sample of 30 learners, right? And then the other thing then that we need to look at is that one, the probability of choosing a girl in that class, that will be represented by P at G. So P at G is the probability of choosing a girl, because we are saying the girls are represented by the letter G, and we read this as probability of choosing a girl. Right, remember to ask any questions if you have got any. Feel free to ask any questions if you have got any. All right, so on this probability one, just to recap, we discussed what is meant by sample space, which will be the number of individuals in that specific environment. And then we said that we can have boys in that classroom, we can have girls in that classroom. So the sum of boys and girls must give you 30, which gives you the sample space. And the notations that we use P into B or P into G, whereby P into B means the probability of choosing a boy, P into G means the probability of choosing a girl, or the probability of selecting a girl from 12A class. All right. Okay. Now I'm just going to erase that and then move over to the next terminology. Okay, let's look at that now. Remember I said P at B is the probability of choosing a boy from 12A. P at G, the probability of choosing a girl from 12A. Now, what will be the probability of choosing a boy? Now we are calculating the value. Remember, we know the notations. So the probability of choosing a boy, how do we express that? We express that as the number of boys in that sample space. Remember, we said we have got 13 boys. So that will be the probability of choosing a boy. We are choosing a boy. What comes on the numerator is what we are talking about, is what we are observing. We are observing now boys. The focus is on the boys. So the number of boys must come on the numerator. I'm explaining how do we now find probability. Probability of boys in a sample of 30 learners, whereby the boys are 13, the girls are 17. So the probability of selecting a boy, so on the numerator becomes what we are observing, which means that are the boys. Then you always divide it by the sample space. Remember that. And this formula is very important. And that is the probability formula. So in this case, then we will say the probability of selecting a boy amongst 12, amongst 30, a sample space of 30 will be 13 divided by 30. Now, what will be the probability of selecting a girl? What do you think the probability of selecting a girl will be? What do you think the probability of selecting a girl will be, knowing that in this class there are 17 girls? So we are looking at the probability of choosing a girl. What will be the probability of choosing a girl in the 12A class that is made up of 30 learners, 13 boys, and 17 girls? Okay, let's see. The answers are coming. All right. Ital, the probability of choosing a boy, that's good. Asane says the probability of selecting a girl, that's very good. Asane. Quiren, that's very good. The probability NHG divided by NHS, that's very good. Haldezos 17 over 30, that's very good. Okay, you all got it right. So the probability of choosing a girl in this grade 12A class will be 17 divided by 30, which is this one. All right. So remember the probability of choosing a girl, remember the probability formula, what you are observing divide by the sample space. So that will be 17 divided by 30. Congratulations, that's very good. You got the correct answer. Thank you. Now, I wrote here, do you agree with that statement? The probability of not a boy. Do you see what I've indicated here? The probability of not a boy. Remember, in that classroom, the elements are girls and boys. It means if you are not choosing a boy, then it will be a girl. So the probability of not boy will be 17 divided by 30. And look at the notation. How do you note the probability of not a boy? So we use B prime. This means the probability of not a boy. Remember, in this classroom, we have got 13 boys, 17 girls. All right. So the probability of not a boy is actually the probability of not the probability of girl. This is one and the same thing. That's one and the same thing. Probability of not boy, it's actually probability of not girl. I was trying to write here, but my hand is not doing me good. This is the same as that. Probability of not girl. Yeah, like this. Good. So the probability of not boy and the probability of not girl are the same. And the notation is B prime, probability of B prime. So in the examination, when you see something like this, it means it's the opposite, the probability of not a boy. So it's not a girl. That's very good, Asane. You are more advanced. That's very good. That's one way of explaining that. So Asane already wrote 1 subtract 13 divided by 30. That's very good, Asane. That's another way of explaining that. That's very good. That's very good. Okay. So now let's look at the next one. So Asane also says, yes, the probability of boy plus the probability of not a boy equal to 1. That's very good. That's what actually I'm going to show you now. If you see here, let me make it like this. Then I go here. All right. Yeah, that is what Asane said. Do you see now? Just look at this formula. This formula is very important, and that is what Asane has already showed it to me. The probability of a boy plus the probability of not a boy. Let's see what that gives us. Remember, the probability of a boy we said is 13 divided by 30. Remember, this value, we found it before. The probability of not a boy we said is 17 divided by 30. These values, we did find them before. So you'll notice that if you add this, they will give you 13 plus 17 will give you 30. So that will be 30 divided by 30, which is 1. So the probability of a boy, of selecting a boy, plus the probability of not selecting a boy is equal to 1. This means this, that the probability of anything cannot exceed 1. So what we're gonna show here is that I'm just gonna do this. Therefore, the probability of B plus the probability of not B will be 1, which gives us that formula, which is very important. That's what I've just said, that the probability will always be between 0. It will be from 1 end and 0. Some, they use the probability line. So say, for example, you are doing a problem on probabilities and your answer is bigger than 1. Once your answer is bigger than 1, it will raise eyebrows because a probability value cannot be more than 1, as we have seen here in these two explanations. And also, a probability value cannot be below 1, because if you see here, the probability of boy and the probability of not boy gives you that sample space, and that is 1. So we are saying a probability can never exceed 1, a probability can never be less than 0, which means further that we can explain this further by saying this. The probability of A, the probability of any event, if it is equal to 0, it means that it is impossible. So the probability of A, if that is equal to 0, we say it is impossible. So it is impossible that today it is Saturday. That cannot happen. So if you say today is Saturday, it is really impossible. The probability that today is a Saturday is just impossible. So the probability will be equal to 0. The probability of 1 means that it is certain. If you find the probability of 1, it means that it is certain. Say, for example, it is certain that tomorrow is Thursday. So the probability that tomorrow is Thursday, it's 1, because it will never change. Tomorrow, it will be Thursday. Okay, so that is explaining where the 1 and the 0 comes from. That the probability can never be below 0 and it can never be above 1. So it will only be from 1 up to 0 or from 0 up to 1. All right. Now, let's look at something also important. We have explained basically the sample space, the selection was the probability of choosing a boy, the probability of choosing a girl, and we also explained that a probability can never be above 1, it can never be below 1, because you saw that the probability of a boy and the probability of a girl always will give you 1 in that sample space. Then what are mutually exclusive events? What are mutually exclusive events? Can you give me an example of mutually exclusive events? Who can give me an example of mutually exclusive events? What do we mean when we say the two events are mutually exclusive? Joy says there is no intersection. That is correct, Joy. Mutually exclusive events means there is no intersection. Heart and diamond, Asane, good. Events without this of a K, Asane, like the previous example, Haldezos, okay, good. I see what you're saying. That's very good. That's very good. Let me see another. Rainbow and snow, Wednesday and weekend on the same day. Yes, yes, yes. That is true, Kiren. All right. Then from what you told me, what are mutually exclusive events? There are events that cannot happen at the same time. Like Asane is saying, rolling a 1 or rolling a 3. Mutually exclusive events, learners, they are events that cannot happen at the same time. Like the examples that you gave me, those examples cannot happen at the same time. Say, for example, you cannot turn left and turn right at the same time. The event turning left and turning right are mutually exclusive because they cannot happen at the same time. So the two events are mutually exclusive. It's like positive and negative on the side of the batteries. So positive or negative. So it's either you turn left or you turn right. They cannot happen at the same time, all right? It's either you turn left or you turn right. Or is very important in this explanation. Why is it important? Because the events cannot happen at the same time. It's either you turn left or you turn right. And or is very important. Or is what makes exclusive, it's what makes mutually exclusive events. The term or is very important. Therefore, you see that I stressed or. It means that in the formula of mutually exclusive event, we have got the term or. So is the probability of A or the probability of B. And the formula is probability of A plus probability of B. Or means add probabilities. Very good, Asani. Or means add the probabilities. Or means add the probabilities. So when we talk of mutually exclusive events, the word or is there. And as Asane is saying, or means we must now add the probabilities. And Asane goes further that if we see the word and, we will do what? We will multiply the probabilities. Okay, for everybody else, then we are saying the word or, it means that you add the probabilities, and the word or signals mutually exclusive events. So when you hear the word or, it means that you're gonna use the formula, the probability of A plus the probability of B. All right. Okay. So let's go on now. Then we say the probability of, this formula is the basic formula. Then we say the probability of A or B. This is very important, learners. The probability of A or B, remember, or is addition, is the probability of A plus the probability of B minus probability of A and B. Probability of A and B means intersection. Remember, if the events are mutually exclusive, so there is no intersection. So A and B means intersection. Intersection. I'm trying to write here. That's intersection. So there is no intersection. So that is why we are saying the probability of A or the probability of B will be probability of A plus probability of B minus the probability of A and B. And A and B is the intersection. And remember, for mutually exclusive events, therefore, it means that P, the probability of A and B, will be equal to what? Oh, Ital, you've already said it here. The intersection equal to 0. That's very good. That's what I was asking. That for mutually exclusive events, it's minus 0 because there is no intersection. And that is why the formula for mutually exclusive events, it's only P or B equal to the probability of A plus the probability of B, but basically it's minus the intersection. In this case, the intersection equal to A0. Not mutually exclusive is when the event is not mutually exclusive. Okay, that is correct, Asane. That's very correct. That's very correct. Okay. Okay, so the formulas are very important. We can have that formula for mutually exclusive events, and then this one is the general formula whereby we let the intersection to be equal to 0. All right. So let's move to the next explanation now. So the probability of A and B is 0 because you cannot have any outcomes in common. I'm explaining that formula there, that here the intersection is 0 because we don't have any outcomes in common. We do not have the intersection. All right. Okay, from there, just look at this again, where this, what do we call that? The probability of A and B is actually the probability of A times the probability of B. So that's what one of you said already, that if we see and, then it means we multiply. If we see or, it means we add. Okay, so and this, the probability of A and B equal to the probability of A multiplied by the probability of B is the formula for independent events. And if the events are not independent, it means they will be dependent. So from these formulas, we said P at A and B equal to 0. And then the formula for P into A and B, the probability of A and B is the same as the probability of A multiplied by the probability of B. That's very important. And if we have the probability of A and B, if that equals the probability of A times the probability of B, then it means the two events, A and B, will be independent events. Right, alternatively, they will be dependent. Okay, just gonna erase that. Then have independent events. The occurrence of one event does not influence the occurrence of the other event. Okay. So as I've said, if they are not dependent, it means that if they are not independent, it means the events are dependent. Okay, so on these slides, we discussed the mutually exclusive events, and the formulas are very important. Remember the formulas: P, probability of A or B, then we add, probability of A and B, then we multiply. And remember, the probability of A or B can be written as that because there are no outcomes that are common. There is no intersection. All right, so let's move to the next problem. So I'm just going to erasing that, and move to the next one. Okay, compound events. Compound events are events that the events are compound provided they involve more than one event occurring at the same time. Those are compound events. Compound events means that more than one events are happening at the same time. So I gave you an example here, turning your head and rubbing your nose. That's a compound event because you are turning your head whilst you are also rubbing your nose. How many times did you turn your head? How many times did you rub your nose? So those are compound events because they can, because the events are two. You are doing two events simultaneously. All right. I'm just going to erase that. And then the tools that we use to denote compound events are contingency tables, tree diagrams, as well as Venn diagrams. So the three tools are the ones that we can use to find the probability of compound events. And the focus of today's lesson will be on contingency tables, Venn diagrams, as well as the tree diagrams. All right, which are useful in finding the probability of compound events. So from now onwards, I want us to do activities and see how do we apply or how do we solve problems involving Venn diagrams, tree diagrams, as well as contingency tables. So how do we solve those problems? Okay, that is what we're gonna do from now onwards, okay? Okay, remember, first, read the statement. Read the statement. It's very important that we read the statement. Remember, I've been saying all along, it is very important that you read the statement. Okay, let's read this statement together. Let's go through this statement together so that we can understand what is in this statement. Remember, if you understand the statement, you will be able to answer the questions. So you cannot just go straight into the questions without understanding what is given. So let's read the statement together and then say, highlight what is important here. So how does the statement read? A survey was carried out with 240 customers. How many customers were involved in the survey? 240 customers. So the 240 customers will be your sample space because we are observing 240 customers who bought food from a fast food outlet on a particular day. So in this fast food outlet, 240 customers or 240 people visited the outlet. The outlet sells what? Cheeseburgers, denoted by the letter C. Bacon burgers, denoted by the letter B. Vegetarian beggars, denoted by the letter V. All right. So here we have got compound events. There are cheeseburgers, bacon beggars, as well as vegetarian beggars. So the question is, then the statement goes further. The Venn diagram, so we are expecting a Venn diagram. Now, because the events are 3 here, a Venn diagram is made up of circles. So how many circles will be in the upcoming Venn diagram? How many circles will be included in the Venn diagram? Let's see, how many circles? Okay, 3, Ital says 3, Mwiponi says 3, Asane says 3, Heldaso says 3, Nyasha also says 3. That's very good. We will have 3 circles. We will have 3 circles. Apiwe also says 3 circles. That's very good. It's 3 circles because 1 circle will represent the cheeseburger, the other circle will represent the bacon and the beggars, the 3rd circle will represent vegetarian beggars. And remember, in this case, the Venn diagram is provided. Joy also says 3 circles. That's very good. So the Venn diagram in this case is provided. We are not supposed to draw it. It is provided, it is given. So I'm going to show you the given Venn diagram. So that's the given Venn diagram. Already we know that the Venn diagram will be consisting of 3 circles. There you are. Does that make sense to you? Look at the Venn diagram. So you have got the C. You have got C here. C represents cheeseburger. That is the circle. Cheeseburgers, they are here. All right. See the cheeseburgers? That circle there represents the cheeseburgers. Okay. That circle there represents the cheeseburgers. And then the other circle, let's see if this, what will be the other circle? I'm just gonna change the color here. See if I manage. No, I'm not managing. Changing the choose pen color. This one, no. I'm gonna remove that in color. You just want to use different colors for the circles so that we all see. So this circle here, the purple circle, you see the circle there, represents bacon beggars because you have got a B here. All right. So the yellow circle is the cheeseburger. The other circle will be the bacon burger. Then the 3rd circle, the circle which is now in red, this one, now represent the vegetarian burger. So I've got the 3 circles there. I've got the 3 circles there. So it's the cheeseburger, which is the yellow one. Then you have got the B, which is that one. You have got the V, which is that. And then in each circle, you can see in the yellow circle, you have got 84, 9, 12, 17. You have got also in the purple one, 17, 52, 3, and 12. So in this one, in the V circle, you have got 58, 9, 12, and 13. Okay. And then you have got 5 outside the circle. What does this 5 outside the circle mean? This is very important. What does that 5 mean in the Venn diagram? The 5 is not in one of these 3 circles. What does that 5 mean to you? It's very important. Those that did not buy anything, that's very good, Ital. The number of people who did not choose any beggar, that's very good. Apiwe, the number of people who did not participate, they did not buy anything. Quiren, Haldezos, Nyasha, people, all of you, you got it very right. You got it very right. So 5 stands for the number of people who didn't buy anything in this shop. All right, so we have got that information there. We studied the information. So let's try to answer the questions that follow. Let's now try to answer the questions that follow now. Okay. Let's try to answer the following questions. I'm just gonna clear that. Okay. Let's try to answer the questions. How many customers did not buy burgers on the day? Are events B and C mutually exclusive? Give a reason for your answer. If a customer from this group is selected at random, determine the probability that the customer bought only a vegetarian burger, bought a cheeseburger and a bacon burger, did not buy a cheeseburger, bought a bacon burger or a vegetarian burger. So those are the 3 questions, whereby question 3 has got 4 sub-questions. So these are the questions that we must answer. But we answer them using what? The given Venn diagram. Let's start with question 1. Let's start with question 1. How many customers did not buy burgers on the day? What's your answer? So let's see. What are the answers? 5. 5. Ital, you said 5. That's 5. Yeah. Quiren, here I see you said 5 divided by 240. Here they only need the number of people who did not buy anything in that shop. So it's going to be 5. So if you say 5 divided by 240, it means the probability of people who didn't buy anything on the day. So here is just, the question says, how many people did not buy burgers on the day? So the answer is a straight 5. Very good. Colossa, you say there are 5. Asane also say 5. Kuren, thank you so much. Yeah. So if you give a fraction, remember a fraction, yes, that's true. A fraction, once you give a fraction, it means it's now the value of the probability. Okay, but when you look at question 1, it just says how many customers did not buy. So they need a specific number. Thank you so much. You all got it right. Thank you. All right, let's look at the next question. What was the next question? I'm just gonna, yeah, that is the answer. 5 customers. The next question, are the events B and C mutually exclusive? Give a reason for your answer. Are those events mutually exclusive or they are not exclusive? What is the answer? Events B and C. Remember, what is B and C? B and C is what? Vegetarian and cheese. Cheeseburgers. That's C. C is represented by this, by that circle. And then also V. I see people are already giving me the answers, which is very good. It's very good. Please put on the answers. Are the events mutually exclusive or not mutually exclusive? Yeah, those 2 events. So let's see what you have written. Let's see what you have written. Oh, yes, that's very good. Haldezo Sapiwe, Haldezo again, Muiponi, Nyasha, Joy, Ital. You all got it right. You are doing so well. Ital, you say no, because there are those who chose C and B. Because, and then Haldozo say no, they have intersections of possible outcomes where multiples can occur. That's very good. Apiwa says no, they occur at the same time. Haldezo says no, they have intersection where more than one outcome. Then Ital say, yeah, yes, Ital, C and V. All right. The two events are not mutually exclusive, as you have said. And the reason is that they are not mutually exclusive because there is an intersection. Remember, for mutually exclusive events, the probability of C and the probability of V must be equal to 0. And here, the probability of C and V is not equal to 0. It's not equal to 0. We have got an intersection in this case. So the events B and C are not mutually exclusive. They are not mutually exclusive because there is an intersection. The intersection is not a 0. You can see that there is an intersection. The yellow circle and the red circles, they've got an intersection. That is the intersection on the diagram. This will be the intersection. That is where they cross over. That and that one gives you now the intersection. So there is an intersection in this case. So it means that the probability of C and B is not equal to 0. It is not equal to 0. All right. Okay, thank you so much for the correct responses. You are doing exceptionally well. Excuse me. All right, let's move on to question 3. So let's check what question 3, what they asked us in question 3. I'm just putting the Venn diagram because we need to use the Venn diagram to answer the questions. What's the possible answer? If a customer from this group is selected at random, determine the probability that the customer bought only a vegetarian burger. The customer bought only a vegetarian burger. What is the probability that the customer bought only a vegetarian burger? So let's see the answers. Okay, 58 divided by 240. Haldezos, Ital, Quiren, Apiwe, Miponi, Asane, Joy, Nyasha, Langanani. I see Nyasha here gave a different answer. Joy also said a different answer from the others. Nyasha also said a different answer from the others. But I see the majority of you here, Joy, Haldezos, Ital, Quiran, Apiwe, Mwiponi, Joy, Langanani, you all said 58 divided by 240 is the probability of people who bought only vegetarian burger. So how did we arrive at this solution? Okay, look at the vegetarian burger. So it will be this one. You see that one. This circle must represent the vegetarian burgers, guys. So now they say only a vegetarian burger. So from this Venn diagram, it will be 58. The number 58 divided by 240. Remember, they say probability. So it must be a fraction. It must be a number divided by a sample space. It must be the number that is observed divided by the sample space. So it's 58. We are leaving out 9 because in this area here, there are also people that bought what? That bought cheeseburgers, as if you can see it there, here. So the 9 is excluded because these people here might have bought cheeseburgers as well as a vegetarian burger. So the correct answer will be 58. It will be 58, which is 29 divide by 120 in its simplest form. You are very correct, Asani. And then remember here also, we will exclude, just check the others also. This area here, 3 won't be included because in this number 3, even though 3 is under this circle, the V circle, but now in 3, you also have the B. Do you see that? In B, if you take the 3, you've got that circle and that circle. So 58 is the one that is standalone. So this one's 12 also is an intersection. So you cannot use that. All right. So that's very good. So you are doing very well. That's very good. Remember to ask questions if you feel that you are lost or if you feel that there is something that you don't understand. Please feel free to ask questions so that we don't leave you behind. Right, let's see the answer that I got. Okay, the probability of V only, that's 58 divided by 240, which is basically like 29 divided by 120. All right, so it's 58 divided by 240. Remember, if you have got a question, type the question in the chat box, please. So 58 here is the correct note. 58 divided by 240 is the correct answer. Remember, examiners encourages you to always give answers in their simplest form. So 58 divided by 240 is 29 divided by 120. And then remember, we took 58 divided by 240 because only 58 customers, only 58 people bought a vegetarian burger. All right. Okay. All right, Joy. That's very good. Yes. 5 didn't buy. 5 didn't buy anything from this shop, but only 58 then would have bought the vegetarian burger. That is very true, Joy. So the 5 is not included. The 5 is not included because 5 customers did not buy anything. So the 5 customers, they are not included on the 58. All right. Okay. So let's look at the next question. Let's look at the next question. Where is the question? Just gonna... All right. You see the question? Determine the probability that the person bought a cheeseburger and a bacon burger. Cheeseburger and a bacon burger. Determine the probability that the person chose a cheeseburger and a bacon burger. What's the answer? Cheeseburger and bacon burger. 17 divide, okay, that's Quiren. Joy also, you have got that. Nyasha, you have got that number there. Gertrude, you have got that. They say cheeseburger and bacon and a bacon burger. All right. Cheeseburger is this cycle, ne? Cheese and bacon. Look at the circle for cheese. That is the circle for cheese. Do you see that? Where does it intersect with the... Okay, that's the circle for cheese. And the other one must be the circle for bacon. Cheese and bacon. So that will be the circle for bacon. Do you see? Is that one? Up to Then, so you're taking it up to here. You cannot include 12, because if you look at 12, because I see some of you here, they included the 12. The region in question is only this one. That's the region that we are concentrating in, whereby the B circle intersect with the cheese circle. The 12 is outside. I see there is somebody who gave me the answer 29. So the answer must be 17 divided by 240. I saw Asane also. Do you all see that it should be 17 divided by 240? Nyasha, yes, I see you said 17 divided by 40. Ital said, Ital, I don't know where the addition you added here. Okay, we are not supposed to add in this case, Ital, this thing now. It did what it did yesterday also. I'm just gonna, okay, that's my mistake. Okay, thank you, Ital. And then Apiwe, can I ask, since 12 did not also buy the cheese and bacon, and the question did not say only, can I ask, say, did 12 did also buy? Yeah, even though they say, they didn't say only, but they say bought a cheeseburger and a bacon, a cheeseburger, and a bacon. So that will be 17. That will be 17. See here, what are others saying? This thing is not your answers. This thing is now showing me something that they didn't click on. All right, I'm just trying to see something here. It seems as if my chat box is doing something which is not fine here. Where is the thing? I'm just recording the chat box, which is not here. I can't see it. But now that is the answer that I got. I'm missing your questions now. Okay, that will be 29 divided by 240, which is what we got. So the majority of, I just want to explain that question again. Now I missed the chart. That will be 29. Not. I've lost my thing here. So say if you multiply C and B, collage judge, you are wrong. I'm just trying to get the chat box. I missed
what
your.
You lost there, Makala?
Here now I cannot see, guys, your chat box. Nhlanhla, can you help me here see the chat box? It has just disappeared here.
Disappeared. There's a red arrow right at the top there.
Oh, okay.
Click it to show that it must pop out.
No, it's
Are you
not.
winning? It's not there. Another thing you can do, you can click on the blue flower at the taskbar. At the bottom of your screen, there should be a blue flower there. Click that.
So it's difficult to communicate with you, everybody, because I cannot see that chat box now. Sorry for that.
Do you see the blue flower on your taskbar at the bottom of your screen?
Yes, but it's not.
Yes, just click it. Let's see if click it and see if it will pop up.
Yeah, there's no.
Still not showing.
Yeah, it's like
it might be. Sorry.
It's like a cycle. Okay, thank you so much. Okay.
Yeah, it's like I said.
I got them now. Thank you so much. Italy said 17 divided by 2. Can I ask, since 12 did not also buy the cheese and the bacon, and the question did not say only Apiwe, mistake, sorry, Colosa testing. Okay, Haldezo, you are responding to the problem that I have. I see that the majority of you are saying 17 divided by 240 for this question, whereby it said the people that bought. I'm just going to do this. How many people bought a cheeseburger and a bacon? Remember, we said we are looking at this circle. Cheeseburger and bacon. That's the cheeseburger. And the bacon. Asane says 29 divided by 240. That will be the circle 29. 17, we said 17 divided by 240. It should actually be 29 divided by 240, because those will be the circles that are in question. That's 17 divided by 240 plus 12 divided by 240. Okay. So that will be the answer to, because if you try to add the C and the B, you will get 29 divided by 240 in this case, which is the overall. All right. Just looking at the problem again. That's the cheese will be that, and then the burgers will be that other circle in there. Now, if you include the 12, remember the 12 in here include also those that bought the vegetarian. But the problem here is that the only part here, I think, is the one that is very important, because they didn't say only. Only. That is why then we get 29 divided by 240. But if they did say only, it would have been 17 divided by 240. That when everyone who bought, say what you are saying, Ital is saying the intersection, Asane, you're saying the intersection. Yes, is the intersection, but you can see that in amongst the 12 here, we have got those that bought the vegetarian and the other, and the bees, the burgers, and the cheeseburgers. They want everybody who want both. But here I get the 29 here. Okay, we include the 12, right? Because they also bought C and B, besides them buying V. Okay, that is very good. Yes, we included the 12, because remember that in this 12 also they bought the B's and they also bought the cheese. Even though this one you can see that the 12 also included the V's, but we are not actually sure how many they bought that. So that's why then now we included it to 29. Unless if they said only, then we would have done the 17 divided by 240. So that's a bit confusing question, but then the fact is that because they didn't say only, then we should include the 12, because the 12 also is amongst, you see that the 12, the circles for V and the circle for C and the circle for B also included the 12, and that will be 29 divided by the 12. Okay. All right, let's look at the next question. I'm just going to clear the handwritings here and then look at the next question. Just look at the next question. Okay, it continues like that. I've just put that. It says, if a customer from this group is selected at random, determine the probability that he did not buy a cheeseburger. What will be the probability that he did not buy a cheeseburger? What do you think the answer will be? That he did not buy a cheeseburger. Okay, this is the circle for cheeseburgers. So what will be the probability that The customer did not buy a cheeseburger, so the customer is excluded from this. What is the probability that this circle is not included? Okay, let's see that the 9 divided by 40, Langanani says 9 divided by 240, 59 divided by 259 divided by 120, that's what Miponi is saying. And then what are the others saying? 118 divided by 240, others say 118 divided by 120. Okay, let's look at the answer then. Thank you so much for responding. I see that I'm getting different answers here. Asane says 59 divided by 120, oops, 118 over 240. Okay, let's see what the correct answer will be. Thank you so much for your responses. I've got your answers here, so let's look at the correct answer. Let's explain. Akero, they say, did not buy a cheeseburger. How many people did not buy a cheeseburger? Okay. Right, that's true. The probability of not C, the probability of not a cheeseburger. Right, remember the probability of not a boy that we started with? Okay, Aldeso says 58 plus 52 plus 58 plus 3 plus 5 is equal to 118. Did not buy a cheeseburger. So 118 over 240. Okay. Okay, let's see what we got. So that will be the final answer. That will be 59 divided by 120. Okay, let's just add that. Let me just add that just to verify. It's 100 and... So you got 59, Asane, you are the one that got the correct answer. 59 divided by 120, because it's just gonna add this 58 plus 3 plus 58 plus 3 plus 52 plus 5 is that. Then you divide it by 240. And then the answer is 59 divided. Because these people, then it means we are adding, just gonna show you, we are adding 58. It is not in this circle. 3. It's not in the yellow circle. 52 also. It's not in the yellow circle. And also 5 is not in the yellow circle. And that gives you 118 divided by 240. And that's another way of explaining that. 118, 118 divided by, remember the sample, the number of people that are there, divided by 240. And then in simplest form, I think that's what Asane is saying there. See, Asane, what you have written there. So in simplest form, we get, is it 59? That's 59 divided by the 120. Okay, that's very good. I believe that everybody can see the argument that we are making in this case. I see in Yasha there you got 59 divided by 8. Ital, I said, okay, you added the 5 Ital. Asane got it right. Haldezos, you said also 59 divided by 120. Miponi also, yeah, you also, Miponi, got it right. And then 118. So the people who said 118 divided by 240, it's very good. Remember, we need to simplify it to the simplest form. And then who else got it right here? 52. Okay, you added that. Okay, Aldezos here, you were explaining how we arrived at that. In Italios, Aldezos, everybody, Asane. Okay, that's very good. That's very good. That's very good. Langanani, you said 9 divided by 240. But I think now you can see, because if they say did not buy a cheeseburger, so it means that it's all the numbers that are outside the yellow circle that I've highlighted. So you'll add 58, you add 3, you add 52, and then you add a 55. Remember, you'll have 118 divided by 240, but then you need to always write everything in its simplest form. All right, thank you so much for answering that correctly. You are doing very well. And then who bought a bacon burger or a vegetarian burger? So what do you think the answer will be in that case? So I'm just gonna clear everything here. Erase everything. What do you think the answer will be in this case? Just normal. I'm just gonna do that. What do you think the answer will be? For number 3.4, bought a bacon burger or a vegetarian burger? What do you think the answer will be? What do you think the answer will be in that case? So try that one. Okay, I see here. Haldezos, you said 52 plus 58 plus 3 plus 5 is equal to 118. Okay, and then Asane said 11 divided by Nyasha, you said 11 divided by 24. Ital 11 divided by 240 plus 3 divided by 240. Muiponi says 151 over 240. Asane 151 over 240. So that is the probability of B plus the probability of V plus the probability of B. Isashek 107 divided by 240. That's a P-way. And then the others also, Nyasha also got that. Okay, let's see the correct answer then. Let's go through the solution now. I'm just gonna do this. So the probability of V or B, 11, Nyasha, you say 11 divided by 24. The probability of B or V. Just gonna click that. Normal. Proceeding. Remember the OR formula? That is correct. All right. Remember the OR formula that we discussed at the beginning? Nyasha also says 11 divided by 24. Then Joy says 11 divided by 24. Okay, that answer you read my explanation. All right, thank you, Aldozos. 151 over 240. Okay, let's see what the answer will be. Remember the formula for OR. Because remember, if we say OR, it means the formula will be the probability of B or V, which is this one. The probability of B plus the probability of V minus the intersection, that is true, minus the intersection of B and V, the bacon burger and the vegetarian burger. All right. Okay, Tal, you see your mistake. Thank you so much. Thank you so much. So the probability of B, you see the probability of B? That's 84 divided by 240. Then the probability of V, 82 divided by 240, minus the intersection. You see the intersection, 15 divided by 240. So our PY says 151 divided by 240. Okay. So I'm just gonna do the normal so that it types the final answer. Okay, that's the final. Okay, thank you so much for those who got 151 divided by 240. And then this you cannot simplify that further. So I'm just gonna. So the probability of B is that's your B. Remember. I'm just gonna go back. Something happened there. Yeah. Then I'm gonna erase everything. Erase the drawings. It's 151. That's 53. That's truth. That's 53 plus 3, and then 52 plus 9 plus 12 plus 17. Asane is trying to give a detailed explanation of how we arrived at the solution there. That's the 58 plus the 3 plus the 52 plus the 9, and then plus the 17 divided by 240. Because the 58 and then the 3, and so we notice this. That will be the explanation. I'm just going to show you here. Okay, because they say the probability of B or that of V, or that one. And then the probability of B is 84 divided by 240. That of V will be 82 divided by 240. Subtract the intersection, because the OR means that it's mutually exclusive. And then remember that the intersection is 12 and 3, which is a 15. So we subtracted the intersection, and that will be the final answer. But now we add the 58. The 58 is included. Then the 52 is included. All right. And then in this case now, remember we are subtracting this. So here it will be 17 minus the 12, and then the 9 minus the 12. Okay, that will give you the 82 divided by 240 over 82 divided by 240. Okay, then the final answer is 151 divided by 240. I'm just going to erase everything there so that we look at the next question. In that case, remember, if you've got anything that you don't understand or something is not clear, remember to ask the questions. Okay, let's look at activity 2. So remember to read the question first. A school organized a camp for their 103 grade 12 learners. I'm just going to read the question and then underline what is important. 103 grade 12 learners were in a camp. The learners were asked to indicate their food preferences for the camp. They had to choose chicken, which is a C. I'm just going to underline that. They have to choose chicken. They have to choose vegetables, and they have to choose a fish. So the following information was collected. So let's see the information that was collected. So two learners do not eat chicken, fish, or vegetables. 5 learners eat only vegetables. 2 learners only eat chicken. 21 learners do not eat fish. 3 learners eat only fish. 66 learners eat chicken and fish, and then 75 learners eat vegetables and fish. That is the information that they got. Okay, please read the statement and make sure that at least the statement makes sense to you. The school organized a camp, and how many learners participated in the camp? 103. But then they have to make a choice when it comes to food. It's C, V, and F. And all these below are the choices that they made. All these are the choices that learners made. 2 learners did not eat chicken, did not eat any of the 3. 5 only vegetables, 2 only chicken, 21 did not eat fish, 3 did not eat only fish, 66 ate chicken and fish, 75 learners ate vegetables and fish. Okay, that's the information which is provided. I'm just going to erase all that. Then look at the question. What is the question? Let's look at the question. Let the number of learners who ate chicken, vegetables, and fish be X. Draw an appropriate Venn diagram to represent the information. Can I just give you, say, 2 minutes to draw the diagram? Okay, those are the questions. Question 2 will be calculating X, calculating that, but let's start with question 1. Draw an appropriate Venn diagram to represent this information. I'm just giving you 2 minutes just to see if you can get the correct Venn diagram. I'm giving you 2 minutes to try the question and see if you can get the correct Venn diagram. So it's 2 minutes, now it's 26 minutes past 4, then 28 minutes past 4, then I will give you the solutions. So try to draw the Venn diagrams. Firstly, there are 3 constraints. So it's vegetable, it's chicken, it's fish. You'll have 3 circles. Vegetables is V, chicken is C, fish is F. So try to get the Venn diagram. One minute remaining. Okay, thank you so much. The 2 minutes has expired. Okay, that's the Venn diagram that I got. I'm not sure if you also got something like that. Just check if you agree with what I've presented here. You look at the first bullet. Okay, Ital says not yet. Anganani says they got it. Azane says they got it. Let's see. Let's just discuss the diagram. So even those who are still busy, let's go through the diagram together and then see if it makes sense to us. Bullet number 1, 2 learners do not eat chicken, fish, or vegetables, ne? So this is the 2. All right. This 2 in the first bullet is neither inside the 3 circles because these 2 do not eat either chicken, fish, or vegetables. So the 2 is outside the circles. Is it true? You got the 2 outside the circle. Is it 12 or 21 there by C and V? By C and V, C and V. Now C, my pony C I got is 2. C here is 2. Just gonna show here. My pony is asking what is in C and 2. So let's see what I have here. So here I've got 2. That's 12. Here I've got X. Because remember, X is the one which is in the metal because everybody, we say let X be all what everybody is eating. So that will be X. X is the intersection of the 3 circles. X is the intersection of the 3 circles. And then here it will be 66 minus X, that will be 5. This is 75 minus X, that is 3. But now let's go through the statements one by one and see if we agree on everything. Where you have 12, say, is it not 21? Let's see my pony where I've got 12. Okay, let's see. Let's go through it one by one and then see what we agree at. All right, so let's look at only. We agree that the 2 is the 2 here, which is outside, because this 2 means that the 2 of the learners didn't eat chicken, they didn't eat fish, and they didn't eat vegetables. It's 2. So let's look at only. Only, that's only 5 learners ate only vegetables. Ne? So it will fall here. That's fine. The 5, it's fine here because this one, they ate only vegetables. So it will come here. And then 2 learners only ate chicken. 2 learners only ate chicken. That's 2. That's 2 here. This ones, they only ate chicken. Chicken there, all right. Oh yeah, Muponi, you are very correct. The 21 is my mistake. 12 here is 21. That's 21. Here is 21. That's very good. That's very good. That's 21. But the other only here is 3 learners. That's the only here also. 3 learners ate only fish. So that is the 3 because they ate only fish. So 3 will only be in the F circle and not in the other circles. And then now, okay, thank you so much, Miponi, for noticing that. Where is the 12 coming from? Okay, Langanali, yeah, the 12 was my mistake. I'm very sorry. 12, it's supposed to be 21. The 21 here, that's fine. 3 learners ate only fish. So I have it there. 3 learners ate only fish. You see the 66 learners eat chicken and fish. You see 66 learners eat. Where is chicken? Chicken and fish. That's region there. That's chicken and fish, which means that it's gonna be 66 subtract the X here, because the chicken will be this region here, and then this one also, the F will be that, but they see that 66 learners eat chicken and fish, so it will be 66 subtract the X for that region only. Because the X here, remember, it included only also the V's, the vegetables. So we must subtract 60 from, that's why then in the 66, I subtracted X. Because in this X, there are also vegetables. Even though the whole thing here is C, the whole thing there it's B, but remember in this is the intersection of the 3 circles, then it will be 66 subtract X. So 75 learners ate vegetables and fish, that will be 75 minus x, because it's only the vegetables. I'm just going to change the color there. It's only the fish, no, the vegetable and the fish. So we subtracted the x because this region here, if you take everything, then you need to subtract the x because the x is for all that. Okay, I hope that you got the thing correct. Say, may I get clarification? 21 learners didn't eat fish. So why is the 21 under vegetables and chicken intersection? Let's see. 21 learners do not eat fish. It's 12, 21. 21, 21 learners did not, what I say in Italy, let's see, I think that, so I don't understand the part of minus x. Okay, let's explain the part of minus x first. Let's explain the part of minus x first. I'm just gonna remove this. You see the minus x, that's what Italy is saying. You see here, they say Italy, 66 learners eat chicken and fish. 66 learners eat chicken and fish, those 66 learners. But remember, amongst these 66 learners, we subtracted the x because the x is the intersection of everything. So it must be 66 subtract this intersection. As you can see, the fish and the chicken, it overlaps to here, but we only need that region here. We only need that region here, whereby it says chicken and fish. Otherwise, if we include the x, if we included the x in this, we would have included the vegetables. So the vegetables are subtracted so that we only have so that we have got chicken and fish. And even here we want for the 75, as you can see on the 75 is vegetables as well as, let's see, what's that, 75 as well as fish. So it will be 75 minus x because it's fish as well as vegetables, fish and vegetables. So remember, fish and vegetables is the whole circles, but now we must exclude the chicken. Otherwise, if we don't exclude them, they would be included in here. That is why then we minus. All right. Okay. Now, I'm just gonna erase all the drawings. And then William is saying something here. Let's see, 21 is 12. Okay, okay, yes. Now, yeah, William, you are explaining it clearly. 21 will be 2 plus 16 plus 5. So the 21 is therefore 16, 22, 16, 2, and 5. Yeah, William, you are explaining it very well in that case. Okay, so that will be the Venn diagram. I'm not sure if there are any further questions regarding that. Okay, now let's move to the next question. Calculate the value of x. How will you find the value of x in this case? Calculate the value of x. How will you find x in this case? What will be your x value in this case? What do you think the x value is? What do you think your x value is? Okay, make all variables equal to 103, Asane, Joy. And then what do we get? What's your x value? What do you think the X value will be? What do you think the X value will be? 71. Efrosius. Yes, Asane. 12 be changed to 21. Yes, that is true. So my pony says 71 after adding everything. So what do you find? X equal to 71. What's the X value in this case? That's 71, Joy. That's very good. Yeah, remember in my case, I used 12 instead of 21, so I got 62. But that is it's because but now if I add the 12, then the answer is 71. The answer should be 71. Remember in my case, I've got a 12 here instead of a 21. So the answer here must be a 21. So this 12 here should be 21. Remember, is our mistake in that other example. The 12 there is a 21. So you add everything and then you equate it to 103. 103 is the number of learners who were in the camp, and then the answer therefore becomes 71. Okay, question 3. The probability of learners who only eats chicken and fish and no vegetables. What do you think the answer is? Okay, thank you very much for getting the 71. That will be the correct answer. Remember, the 12 is changed to 21. The probability of learners who only eat chicken and fish and no vegetables. So what do you think the answer will be? Chicken and fish and no vegetables. Joy, you got 68. So what did the others got? Italy got 4 divided by 103. I'm not sure if others got that. Only C and V, but not, only C and F, but not V. -6 X, which gives us -5, divided by 103, my pony. Okay, Nyasha. Nyasha, I'm not sure what explanation is. So the answer is 4 divided by 103. So I got 4 divided by 103. So I'm just gonna explain there, how did I get the 4? Oh, that's Q squared. 4 divided, only eats chicken and fish and no vegetables. Only eating chicken and fish. So let's see here. Chicken and fish. They only eat chicken. What is chicken? It's chicken and fish. So X is 71. That's very correct, Nyasha. So you get, when using 12, X will be 62, which is less than 66, but when using 21x, x is more than 66, which is 71. That is why I got a negative value for the probability. Okay, yeah, that is correct, because mine here I used the thing here. I used the 62. That is why I got the that is why I got the 4. But then remember the x is 71. Remember I got the 62 because of that 12, which is a 21. So the answer must be 71. And remember that the probability is always a positive number, so it should be a 5. All right. Because the probability is always a positive number. Remember we said a probability is a number that is lying between 0 and 5. So you'll get the absolute value of that negative 5, which changes to the answer being positive. Okay. So for those who stays, the answer is -5. It should be a positive 5 because the probability is always a positive number. Okay. Remember, my point, probability is always a positive number, so the answer must be a positive number. Okay, let's look at the next question. Let's look at the next question. Just gonna click here. So the next question is on contingency tables. Just read the statement and see if you can follow what's in the table. Ninety people were interviewed on whether they preferred sweet foods or savory foods, and the results were recorded in the following two-way table. Okay. Okay, that's the two-way table. So you have got the totals here. So savory is 33, 21. So 33 and 21 gives you 54. So I'm adding vertically. And then the sweet will be 22 and 14, which gives you 36. So these are the totals going down there. And then the males, how many males were participating in this study? How many males is 33, 22, that gives you 55. So horizontally, you have got males, and then you have got females. Females are 35. So the sample size is 90 of the total number of the individuals that participated in the study. Okay. So let's look at the first question. What's the question? Those are the questions. Determine the probability of male, the probability of savory, the probability of male and savory, the probability of male times the probability of savory. Does the data collected from the survey show that food preferences are independent of the gender? Let's look at the first question. What do you think the answer to the first question is? The probability of male will be equal to what? Using the table, what do you think the probability of male will be? What do you think the probability of male using the two-way table? Is 55 divided by 90. So I see here Muiponi 55 over 90, Aldazos Orekopantse 55 divided by 90. So I see William, you only wrote 55. Remember, William, it must be 55 divided by 90 because they say probability. Remember, we are saying, okay, yeah, that's very good, Kathela. So Asane says 11 divided by 18. 11 divided by 18, I think you wrote it in the simplest form, which is fine. Let me check. 55 divided by 90. 55 divided, yeah, that is 11 divided by 18 in simplest form. Remember what I've said, everything must be written in its simplest form. Okay, that's correct. That's correct for that. Thank you so much for the wonderful answers. I got 55 divided by 90, which is 0.61 in simplest form. Remember, it doesn't matter. You can write it as 11 divided by 18, or you can write it as 0.61. There won't be any penalties there. All right. Okay, let's look at the next question. What is the probability of savory? What do you think the answers will be? Savory 54 divided by 90, 3 divided by 5. Asani. I see Haldezos also gave me the correct answer. That's very good. That's very good. You are doing very well on this one. 3 divided by 5. Remember to write the answers in simplest form. I know that sometimes as learners we forget to write answers in simplest form. Okay, that's very good. Nyasha, you got 3 divided by 5, which is a good solution. That's good. So I got 0.6. I was just writing my answers in decimal form, which is still fine. And then the next question, what is the probability of male and savory? What answer do you get there? What is the answer? Please remember to ask questions if there is anything that you don't understand. The probability male and savory. Male and savory. 11 over 40, Haldozos. Orokopanse says 11 divided by 30, which is still fine. And then in the simplest form, Athane, that's very good. 11 divided by 40. Miponi also got it right. Everybody got it right. You're doing well on the two-way tables. That's very good. Thank you so much. So let's move to the next question. Remember here, you just read the savory and the say savory. If I'm just going to show you here how we arrived at the answer. Savory and male. That will be 33 because it's where savory and male intersect. So it's 33. Remember, it's probability. Then we divide by 90. And then let's get to the next question. The probability of male times the probability of savory. What do you get? What's the answer? Thank you so much for participating. I see you're doing very well. You're getting correct answers, which is encouraging. That's very good. Number 4, what do you think the answer is? The probability of male, 11 divided by 30, Umkarabetse, Muiponi. Let's see what I got. Yeah, that is the right answer. 11 divided by 33 divided by 90, that is correct, which is 0.37. And now the last question now in this question, in this activity, do you think the two events are independent of gender? Does the data collected from the survey show that food preferences are independent of gender? Give a reason for your answer. What is your answer? What do you think? What do you think? Are they independent or not independent? Does the data collected from the survey show that food preferences are independent of gender? William says yes, they are independent. Haldoza says they are independent. Yes, that is true. They are independent. What is the reason? Yes, Langanani, you're saying they are independent. Yes, that is true because the probability of male and savory equals the probability of male multiplied by the probability of savory. Remember the formula for independency. Remember the formula for independent events. We said two events are independent provided the probability of these two, if you multiply them, they are equal. If the two are equal, then it means that the two events are independent. And in this case, the two events are independent because the probability of male and savory is the same as the probability of male times the probability of the savory. Okay, thank you so much. So let's look at the next question, which is our last question for today. Activity 4. So I'm just providing you the answer there and then see if that answer makes meaning to you. A fair coin is flipped twice, so you'll have got two outcomes. So that's the first flip. That is the first flip. And the second flip is that. Remember, if you flip it once, if you flip a coin, it's either head or tail. So the first flip, it will be a head or a tail. Then the probability here is 1 divided by 2 because I'm expecting two outcomes. If I flip a coin, there are only two outcomes. It's either a head or a tail. And then if I flip it twice, I will still get a head or a tail. So it's 1 divided by 2, 1 divided by 2. Remember, if you go up, you multiply. So it's head, which is double H. Then it's head and T, that's head and T. So the other one will be T and H, that's T and H. Then the last arm will be T and T. Remember, going up, we multiply. Vertically, you add. So you can see that H and H, that is when I say H, head, and head here. So that gives you the double head there. All right. And then the other one, if I say head and a tail, then I get this one, head and a tail. So then remember, head and head, the probability of head and head will be 1 divided by 4. So everything will be 1 divided by 4. And when you add vertically, when you go vertically, you must get a 1 because the sum of the probabilities is always 1. The sum of the probabilities is always 1. So that's how the diagram will look like. All right. So let's look at the other question in this activity, which will be our last question for today.
I don't think we'll manage the other question.
All right. Okay. Thank you. Thank you.
We left with about 2 minutes. Maybe we can just wrap it up.
All right. Thank you, Ntlanhla. Thank you so much, Leonard, for attending this session. So tomorrow we will be doing Euclidean geometry. Thank you for the contributions that you make. So we will meet tomorrow again at 3 o'clock when we will be doing Euclidean geometry. Thank you so much and goodbye.
Just a quick one then, Tatematla. Tomorrow's session starts a little bit later at 4:15.
Okay. All right. All right.
Hello, everybody. Yeah. Let's meet tomorrow at 4:15. Our last session starts a little bit later at 4:15. Thank you so much for tuning in. Let's meet again tomorrow. Bye.